Hey folks, in this video we're going to take a look at how to implement a stack ADT in C. Now as a first step towards it, we're going to basically design an outline for it. So we're not going to jump straight to the C implementation, we're just going to design this sort of outline for it. So what do we need to do? We already have this idea from our previous discussion on three key things we need to do in order to support objects. So we need to store something in state, we need to construct it, destruct it, invoke behavior on it, right? So that's what we want to do. Okay, so how can I start thinking about doing that in C? So on the right hand side, I kind of already have a little bit of an outlining started, just so I have less to write, and you guys have less of my handwriting to suffer through. So what do we do? So our first step, right? So we all know what a stack is, right? So a stack is basically this data structure. It looks maybe something like this. We have kind of a visualization here, right? Where it's like you add things into it, and you maybe take things out of it, right? And there's some sort of an order, right? So maybe I add A, then B, then C. Well, if I want to add something else like a D, it'll go on top, right? Or if I want to take something out, C will have to come out first, right? There's a certain order to this collection, right? I put things in, right? I take things off, both from the top, right? You think of it maybe as being like a stack of books or a stack of dishes, something like that. And we have the names for these operations, right? This would be something like we would call this maybe a push operation. It's kind of a typical name. Over here, maybe we would call it a pop operation. So this is what we want to build, but we're building in C, so maybe it's a little bit different than what you've seen before. Probably you've seen this in Java, right? It's easy to maybe implement this as something like a class. Here it's going to be a little bit more work. So what do we do? Well, first of all, what we want to do is have some way to represent the state of this class, right? We want to basically implement this thing, right? I'm using here maybe the words class and ADT a little bit interchangeably. So class, right, kind of defines the blueprint, right? Basically, we want to have this blueprint that we can build objects from. And then ADT is maybe a more specific term. It means abstract data type. And that's basically a way of talking about the fact that we're building this stack thing, right? So the stack is actually meant to do work, right? It's meant to store data and apply these rules on how you handle it, right? It's an abstract data type, right? It stores things and has some operations defined on it. So, okay. So our goal here, right, is basically to try and figure out how we could possibly implement this thing in C. And we're not going to do it, in detail. We'll do that in the next following videos. But for now, right, we're just going to do an outline, right, of what to expect. So let's think for a second. Our first step is going to basically be to store the state of this object. So what do? I already kind of suggested that we would have something that looks like a struct, right? A struct might be a good idea for how to store things. It's a way to bind together data. So what can we think about doing? Probably I'm going to need to at some point build a new stack, and I'm going to start filling this in. My syntax won't be quite exactly right, but we'll get it in another video. But I need to bind data together. So let's see, what do I need to do? So this is a stack. What should I do? Probably there will be a couple things I need to store, and I'll just kind of call them out. This isn't a data structures class, so I'm kind of assuming you have some familiarity with these things already. Probably we're going to need something like, for example, a size. That might be useful, right? So I can kind of keep track of how many things are inside of my stack. So maybe I'll have like an int size. That might be something to start with. So int size. You can imagine this is a struct here. Okay, so I'll have that. What else should I have? Well, I'm going to need a way to store my data, right? A stack is a collection. It has a bunch of things in there. I could probably use an array. I could probably use a list. I think it'll make more sense though if we use a list. Usually that'll give us faster performance for adding and removing items from a collection. Array, typically you have to worry about resizing it. So let's just go with a list. So I'm going to put in here that we have basically a node pointer, right? So hopefully the syntax is starting to get a little bit more clear, right? With a star, right? This represents a pointer. And I'll call this head, right? So that's going to be a typical name for the first element of a linked list. So there we go. That's all the state that I need in my object. Now, if I needed to have something else, right, I could just continue adding variables here, right? So I could add something else here, right? Something else, right? Could be here, right? I don't know. Point is, right, is that every little piece of data that my object wants to have will just need to be placed inside this struct, right? So I can have whatever I want here, right? I just have size and head here, right? But I could have something else as well if I wanted it. Okay, so this is my first step, right? So I built a way to store all the data. What do I need to do now? Well, what I want to do now is basically figure out these functions for manipulating it. So the first thing I want to worry about, right, is this construction and destruction steps, right? So I need a way basically to do that, like new keyword. So what should I do? Okay, so stack create. So I have here basically some outlines. So I want to create this, right? This is going to be a constructor. I want a method, right, that can create a new stack and return it, right? And it'll return, right, a new pointer, right? So, okay, so let's look at this. Stack underscore create. First of all, this is going to be my notation, right? So notice I have here the stack underscore in front. That's going to be the way I designate these functions as all belonging to some new ADT that I'm building, right? Is by putting that in front. So they'll all be stack underscore, right? It's going to be a standard thing. So what do I need to do? I want to build a new stack, so I'll need to figure out kind of what this function should look like, right? Now I'm just going to do this kind of, off the top of my head. Again, I don't want this to compile yet. What I want to kind of do is just, build an outline for what I want to build eventually. So again, right, our goal here is we want to have some sort of a function for creating a new stack. Well, if I want to create a new stack, probably I won't need to have any parameters. I can just kind of call it and say, okay, you know what? I just need that. That's the equivalent of a default constructor, right? In Java, you don't give it any arguments. It just is what it is. Okay, and then what I'll have to do, let's see, I create a new stack. What I need to do basically is return a pointer to it, right? So I build a new stack. Let me get a pointer back from it. So over here, maybe I'll write something like this. I'll say that the return type will look something like stack star. Okay, so that's kind of going to be one of the first methods I need, right? So stack star, stack underscore create, open close parentheses. So that's roughly like me creating a new constructor. So what do I need to do next? I have a way to create this thing. Now I need a way to destroy it. So I have this new one down here, and it's called, right, or it's described as destroy as a stack. So I need to have another function over here, stack underscore destroy. So what do I want to do there? What should I have as arguments? Well, it's destroying something, so I probably need the thing to destroy. So I'm going to go ahead and put in here, and I'll call this, we'll call this a stack star. We'll just call it S, right? So it takes in a stack, and maybe it doesn't return anything at all because, hey, you've just destroyed it, so what could you possibly have to return? So we'll make that a void return type. Okay, so this is basically a destructor. This isn't something you would have seen in Java, but if you're familiar with C++, this is something they basically support, right? They have a special way of defining this destructor, right, with this tilde operator that lets you have a bit of code to call when you want to destroy something. Now for us, this is very important because in C, we need to manually do memory deallocation. We don't automatically have a garbage collector that can go and clean up everything for us. We need to do it ourselves. And so here, that's what we're supporting. We're creating this new function, this underscore destroy, that'll let us be basically, it gives us basically a stub for places to put code to do our deallocations when we need to do them. All right, so these here basically are ways that we can basically create and destroy our object. So these seem pretty good. These kind of map over here, okay? Then just to highlight this one over here, this maps over there. All right, so we have our way to create it, we have a way to destroy it. What else do we do? Well, we need to invoke some behavior on it. So we need to support push, we need to support pop. So push and pop, I kind of can figure out my function names are pretty easily, right? Stack underscore push, right? Stack underscore pop, right? Those are pretty straightforward. What do I need to do? Well, I need to figure out how they look. So stack push, right, is basically going to add an element to the stack. So what can I do here? This is where things maybe are going to be a little bit interesting. I'm going to give it a return type of void to start with, just to make things simpler for ourselves. Obviously, if we're pushing something, we're not getting something back out, so I can just say, hey, I don't get any return result. But over here, this is what's going to be a little bit more work. So I have basically my stack push, and I need to think about what operations or what variables to pass in. Now here, right, what I'm actually going to have to do is I'm actually going to pass in a instance of the stack struct, because otherwise I don't have anything to really work with. I don't have any data to manipulate. So I'm going to have to actually pass in a stack star. This stack star, and I'll call it S again, is a stack I want to do the push onto. Then I'll have over here, and I'll just call this a, well, I don't really know what's going to be added to my stack. Let me just go with an integer for now. Ideally, we'd make it a little bit more generic, and we will, but for now, let's just say this is an integer. Let's pretend that says int that we're being passing in, right? So int, and we'll just call it e, right? So that's the element being passed in. And so yeah, this is how we implement a method, right? We basically have a method here because it's this function, right? Stack underscore push, and we take in the thing to edit, right? The object's data, and then we have this integer, right? Which is the thing we want to add, right? And this function will basically look at that e, right? That element, and modify s to now contain e, right? So this is our object. This is our object's method that we've just implemented here. The final thing we have here is stack underscore pop, which is to remove an element. And so here, right, my return type is going to be something like int. And then here as my arguments, right, I'm going to need basically my stack s again, right? I need some place to, to edit. Stack s, there we go. All right, so those are our basic methods. That's our basic way of storing data. This is what we're going to do, right, in C in order to basically implement this object. And what you're looking at here, actually, okay, so let me before I spoil it. So this is how we're going to implement our objects. Now think about this for a second. I have some questions here. First one for you to think about for a moment is, where's the class? Well, this is the class, right? So I literally have here, right, a way to build this thing, right, to build objects and then to make them act as objects. So I have these functions I can call underscore push underscore pop to make a newly created struct, right, the struct stack act like an object, right? So what we're looking at here really is the entire class, right? So everything you see there on the screen, right, all this code here, this is all really just a class, right? It's not written like a Java class, right? I mean, maybe it is, right? You can almost imagine, right? Maybe you have the keyword class is over here, right? Maybe you have like class, right? Maybe. And then you're like, well, I got all this stuff inside, right? Maybe you can almost picture that. You gotta be careful, but you could almost think of that, right? You have your data, you have your constructor, you have your methods, right? So this whole thing we're looking at here, right, is a class. Second question for you to think about for a second. Where is the instance here? Well, the instance is really this over here. So my struct stack, right? So this is my bit of data, right? That's my instance data, right? For all the different objects, right, they all have the same behavior. They all have the same functions / methods on them. What's different, right, is those instance variables. That's really the instance, right? And that's what I've circled here, right? That struct stack stores all of the instance data. All right. So that's kind of how things are working right now, right? So hopefully you can see this there's this idea of a class here, idea of an instance here, right? That's what we're looking at right now. And if we have this, right, we'll basically be able to create objects, right, in our C program by calling that stack underscore create function. Okay, so that's all I got for you guys in this video. And next video, we'll start actually implementing this.